All right, so this is topic 5. We're going to do the first lesson, and we're going to explore absolute value equations and inequalities. We're actually going to stick to just equations in this one, and we'll do inequalities in the next lesson or next video. So let's review what absolute value is. It's a distance from zero. It's a number's distance from zero. And if we think about that, we typically would place 0 on a number line. And we come up with a few examples like -4 and 4. And if you recall, the way that we represent absolute value is we use these absolute value bars, is what I like to call them. And so the distance that -4 is from 0 is 4 units, +4. And the distance that 4 is from 0 is also +4. It's important to note that the absolute value of any number such as x, cannot be a negative. Cannot be a negative, okay? Because we do not deal with negative distance when we deal with distance. It's just not negative units. Okay, so side note here, if you want to take that, write that down as a refresher in your notebook, that would be great. Pause it and then keep going when you're ready. So let's look at a few equations that deal with this absolute value symbol in them. We'll start off with a fairly simple one. We're solving for x. We want the absolute value of x. So we're going to solve as normal. We're going to take off the +2 by undoing it. And we get 5 equals the absolute value of x. Well, this one was pretty simple. We now know, because we're dealing with absolute value, there's 2 possible choices, right? You can have a negative or a positive. So how we're going to write this is, we're going to think of this as x equals 5, but x can also equal -5, and it will still make the equation true. So hold on to that thought for a moment. Notice that we just split this into 2 different equations. We're going to follow this procedure even when our equations get a bit more difficult. Let's do another one. So if we have, I'm going to get rid of this one and this one. If we have the absolute value of 2x minus 3, and that equals 1. Well, our portion here with the absolute value, it's already an expression that's isolated. So from here, just like we did with the 5 equals absolute value of x, we wrote it into 2 separate equations. We're going to do the same thing here. We're going to drop the bars because we're now talking about negative and positive options. And we're going to say that 2x minus 3 equals 1. But we're also going to say, beside where our absolute value bars were, that negative 2x minus 3 equals 1. Remember, x was inside of the absolute value bars. So it can either be a positive or a negative. And we do need to distribute that now. Okay, if it's an expression, you're going to rewrite it, but you need that negative in front of the parentheses. So this actually becomes negative 2x plus 3 equals 1. And this one is 2x minus 3 equals 1. This was our original one. So let's solve this. We add 3 to both sides. 2x equals 4. So x equals 2. Over here, we subtract 3 on both sides. We get negative 2x equals negative 2. So then x equals 1 when we divide both sides by negative 2. Okay, so now we are going to plug this into the original, both of them, and make sure that it checks out. Let's check our answer. So if x is 2, we have the absolute value of 2 times 2 minus 3 equals 1. Well, this is 4. 4 minus 3 is 1. And 1 equals 1. The absolute value of 1 does equal 1. That one checks out. Let's do this one. Absolute value of 2 times 1 minus 3 equals 1. Well, this is 2. 2 minus 3 is negative 1, but we want the absolute value of negative 1, which is positive 1. So that one also checks out. It is very, very important that we check our answers because we get 2 different x values. It's very important that we check into the equation, make sure that it's correct. Okay, we're going to do another one. This one's got more steps involved. So let's do 3 times the absolute value of x plus 6, then add 8 equals 5. Now, it's important, these are absolute value bars, but because there's a 3 and it's not, there's no symbol in between, it does also mean multiplication, okay? We're not going to distribute. We're not going to distribute. We're going to eliminate the extra steps that we need to take. So we are going to subtract 8 from both sides. That's what we would normally do. And on this side, we have -3, and we've now gotten this closer to being isolated. Our goal is to isolate the absolute value portion of the equation. So if this is multiplication, we're going to divide to eliminate that 3. Now we're left with absolute value of x plus 6 equals -1. I know, so absolute value can never equal a -1, okay? So here's what we're going to do. This right now should be telling us that there is no solution. Because how can you have the absolute value of something and it equals -1? But let's proceed with our process and check it out. So here we would have x plus 6 equals -1, write it how it's originally written, but drop the bars. And over here, we're going to now put negative x plus 6. Remember, this part is now, it could be a negative, equals -1. So let's come over here and solve. We're going to get x equals -7. Over here, we're going to get negative x minus 6 equals -1. We're going to add 6. So this means that so if negative x equals 5, then positive x equals -5. We just divide that negative out on both sides. So let's go back to, let's see, we could actually use this one. It's got less steps in it to check it, but you can use this one or this one. I'm just picking this one because we divided out the 3, and so this is an equivalent equation, okay? Just like equivalent fractions, this is an equivalent equation. So let's try it. We have the absolute value of -7, plugging this in, plus 6 equals -1. Well, we know this isn't going to work, right? Because this is -1. The absolute value of -1 is not -1. It's +1. Let's try this one. Absolute value of -5 plus 6. Again, we're still stuck with this equaling a negative, so this is also not going to work. So in this case, because this becomes a 1, 1 does not equal a -1, especially the absolute value of it. So that is not going to work. These aren't going to work. So now we're going back to the idea that, hey, once I got here, and I know I did these steps correctly, this should not have resulted in a solution. You cannot take the absolute value of any expression or number or anything, and get a negative answer. So in this case, we have a situation where there's no solution. Let's look at another one. This one, taking a step back, is a few steps less than the last one, right? So this part is already isolated. We got our absolute value expression alone on one side. So now we're going to generate our two different equations. One of them is going to be written the same exact way, only without the bars. The other one is going to be the negative, taking the negative of this expression, and then still equaling the same amount. So over here, we're going to add 6 to both sides, divide, and the answer is 6. Over here, we're going to distribute first, subtract 6 on both sides. Oops, that's not a negative. We subtract 6, we get positive 6. We divide both sides by -3, and the answer we get is -2. Now it's time to substitute and check. Well, 3 times 6 is 18. 18 minus 6 is 12, and the absolute value of 12 is 12. So that works. Over here, 3 times -2 is -6. -6 minus 6 is -12. And the absolute value of -12 is +12. So in this case, we have the solutions, 2 of them, are 6 and -2. Both of these satisfy the equations. Now, there could also be a time where we solve and only one of them works and the other one doesn't. So in that case, it would be one solution if only one x value is true or makes it true, okay? But in this case, we have, so this is just a side note. But in this case, both of them do, so there's actually 2 solutions. And I don't know if you remember, but this came up on your final, and you were like, well, how can there be 2 solutions? Well, in a situation with absolute value, there could be 2 solutions. So now you're going to do a few practice problems and make sure you reference your notes.